All right, so here we go. On number 1 through 4, let me see what color I have. We're just examining all the different types of forces acting on the apple itself. So 1 is just hanging on the tree. So gravity is present in all 4 situations. As long as it has a mass, it is going to be present. So I'm just going to kind of pre-draw everything in so that you just have the understanding that it is the same, because the apple should have the same mass, and it's all being pulled down. On the first one, the apple is hanging from the tree, so there has to be an equal and opposite force keeping that apple from falling to ground. So we could call it force of the tree, force applied, whatever. But in this case, sum of all forces is equal to force of the tree plus force of gravity. And since this is equal to 0, because it's not moving, force of gravity negative is equal to force of tree. So equal but opposite forces. Number 2, it is falling but without air resistance, so this is the only force present. So sum of all forces is equal to Fg. It's unbound, so this time it's not. Here we have Ma, which will be equal to mg. So in this case, mg. In this case, the acceleration is equal to the force of, the acceleration of gravity. The next one, it's falling with air resistance, and it should be smaller. Air resistance should be smaller than gravity. So the sum of all forces in this case should be negative because gravity is bigger. And the last one, apple is on the ground. And on the ground it's not moving any more down, so there has to be a force normal keeping it up. So in this case, sum of all forces is equal to 0 again. So force of gravity negative is equal to force normal. Need something?
Is it light?
It is.
Oh.
All right, so that is that problem. So I don't think I did this right. This should be sum of all forces in the y direction is equal to negative because there's only gravity. Sum of all forces in the y direction is 0, like I said up here, because it's balanced. The apple's not moving left and right, so for the x direction, they're all 0. All right, the next set. 5, 6, and 7. You have squirrel pulling an apple across the ground. So that's force applied. And the first one is with friction. So friction is the opposite of direction. So if it's pulling this way, the direction of motion should be that way. There's 2 forces as well because it is on the ground. You have force of gravity and force normal. It's not moving up or down, so sum of all forces in the y direction should equal 0. Sum of all forces in the x direction should be positive or to the right because force applied is bigger than force of kinetic friction. So if you wanted to write it out, it would be force of kinetic friction plus force applied. Number 6, you have no friction, so exactly the same thing. Force of gravity, force normal, force applied, but in this time you don't have friction over here, so sum of all forces in the y is still 0, sum of all forces in the x is still positive, but this time there's only one force, which is just force applied, so it should be going much faster without friction. The last one, you have the dog and the squirrel. It doesn't matter which way you do it. So let's say this is force of the dog, and let's say this is force of the squirrel. It should be smaller. And the trick here, not really a trick, but the hardest part here is determining which way friction is. Since the dog is pulling bigger, the direction of motion in this case is this way, direction of motion. And friction is either the opposite of force applied, in this case there's 2 of them, or the opposite of direction of motion. In this case, direction of motion is that way, so that means friction is going to be this way, force of kinetic friction. Okay, so sum of all forces, in this case in the y, is still 0. Sum of all forces in the x, let me just make sure. We don't know if it's 0 or positive, just it depends on how much friction is, and depends on how much the dog's pulling, and depends on how much the squirrel's pulling. Most likely the dog is winning, so most likely it's positive, but either one is fine. 0 or positive, it can't be negative. Okay, 0 because it could be constant velocity. Okay, just in case you're wondering how it could be 0. For 8, 9, and 10. For 8, you have a rock that is being flung out in a slingshot. So this is when it's still attached to a rubber band, so that we could call this force applied. I'll be happy with this one, but technically the rubber band's doing two things. It's flinging it forward and fighting against gravity. So either one is fine for me. This is kind of more of a technicality. It's not, to me, it's not a big deal. For me, the big deal is this one. Sum of all forces in the x direction is positive. It's speeding up. In this case, y is 0. Okay, for the second one, it is flying through the air and it's no longer in the slingshot. So gravity always, if it's in the air, gravity is going to be there and it's always negative. And then in this case, there's also a force of air resistance. So here we have 2. Sum of all forces in the x is negative. Sum of all forces in the y is also negative. It's going to fall and slow down, depending on how fast it's going. And the last one, finally the slingshot hits the ground and starts to skid. So you have force of kinetic friction, force normal, and then force gravity. So it should not be moving in the y direction anymore, so it's 0. In the x direction, it should be slowing down because of friction, so it is negative. So those are the free body diagrams. Hopefully it made sense. Now let's get on to the friction problem. So you have a refrigerator that has has a mass of 140 kilograms, and you have a force of 225, and then you have a friend that's also pushing at 255, and you want to know if this thing is moving. Okay, so that's the question. What is it doing? So first thing you want to do is figure out the two different frictions. You have static friction, which is mu s Fn, and then you have kinetic friction, which will be force of kinetic friction is mu k Fn. Okay, so to make life easier, I've always just, once we do forces, to do everything in your head, just multiply by 10. So 140 times 10 equals 1400. Force is negative because it's down, so that means force normal is positive 1400 newtons. Okay, so we could plug that into here. Static friction, mu on this sheet is 0.25 times 1400. And when you multiply that, you should get 350. Okay, that is force of static friction. This is smaller than these two together. So remember, one person's pushing 225, one person's pushing 255. So 225 plus 255 equals 480 newtons. So 480 is bigger than this one. 480 is bigger than 350, so it moves. Okay, once it moves, it is no longer static friction, but now it's kinetic friction. So you do the same thing. Mu for that is 0.15, still times Fn, which is 1400. And when you do that, you get 210. So now you have 480 and 210, or you could just add them all up. This is force of kinetic friction, which is 210 negative. So sum of all forces, or F net, is equal to 225 plus 255 minus 210. And then when you do the math there, I'm going to cheat and look at my answer sheet. I get 270. And you have A times the mass, which is 140. And then 270 divided by 140 should give you 1.92 meters per second squared, positive. So this thing, even with friction, is accelerating to the right at 1.92 meters per second. All right, the elevator problem. So in the elevator problem, we really only care about the person. So I'm going to do A, B, C, D. This one's at rest. This one is constant. This one has acceleration of positive 2. And this one has acceleration of negative 4. Okay. You have a person And that person is experiencing 4 different experiences. But that person has a mass of 75. So if it has a mass of 75, no matter what the situation is going on, force of gravity is going to be the same. 75 kilograms times 10 meters per second squared. And that's going to give us an F of G of 750. Since gravity's down, it's going to give us negative 750. So all these guys, no matter what's happening, has a force of gravity of negative 750 because your mass doesn't change. So I don't care if you're being flung upside down, flying in a plane, gravity's going to work on you exactly the same, 750. What's going to be different is how much Fn this person's going to experience. So at rest, right, A is equal to 0. So sum of all forces is equal to force normal plus force of gravity. Since A is 0, that's 0, so force normal plus force of gravity. If you move gravity to the other side, get negative force of gravity equals force normal. So equal but opposite. So if this is negative 750, this one is positive 750. Constant. That means A is also equal to 0. So it's the same problem. If Fg is negative 750, this has to be positive 750. Okay? For this one, A is 2, so it's not. So I can't kind of skip it. So I have F net, or sum of all forces, is equal to Fn plus Fg. M, which is the mass of the person, 75, times A, which is what we have up here, 2. And it is positive, equals Fn minus 750. 2 times 75 is 150. And I move 750 over, plus 750 equals Fn. So in this case, Fn is equal to 900 newtons. Okay, I always like to do a test. Okay, which one is bigger? 900 is a bigger force, so that means it should be accelerating up, and it is. So we're good. All right, the last one. Exactly the same thing as this one. Pretty much copy it, except instead of 2, I have negative 4. Fn minus 750. Negative 4 times 75, I believe, is 300. Let me cheat. 4. Yeah, 300. 300. So if I add 700 here, or sorry, 750, I don't get a bigger number, I get a small number. I get 450 newtons, which is equal to force normal. And then you could check again which one is a bigger number. We don't care about signs. Signs just tell us direction. So which one's the bigger number? 450 is smaller than 750, so that means it's going to be accelerating down. And it is. It's a negative number. So that's what we're looking here. Remember, Fn is your apparent weight, how heavy you feel. So when you are accelerating up, you should feel heavier because it's bigger than your normal Fg. And then if you're going down, accelerating down, then you should feel lighter. So that's kind of how you feel, either heavier or lighter. All right, the fish problem. So this one's kind of a trick. It wasn't meant to be a trick, but it's kind of a trick, and I'll kind of show you where. So you have a fish that is 7 kilograms on a line. I did say the max tension is 60 newtons. And right away, you might see something that happened, which is that if you calculate the two forces that are here, before you even get to tension, something happens here. Force of gravity is equal to 7 times 10. And that's 70 newtons. So already gravity is bigger than the max tension, so technically it broke, so the fish never got caught. Now, let's say tension wasn't 60 and you wanted to find T. How would you do it? The acceleration was positive 3 meters per second. So what you would do is set up sum of all forces is equal to tension plus force of gravity. Ma equals T plus mg. Plug everything in. M is 7, A is 3, positive, equals T minus 70 newtons. So if I move 70 over, 3 times 7 is 21. So 21 plus 70 equals tension. Tension's equal to 91 newtons. So if max tension was bigger, then and it could handle at least 100, then the tension will be 91. In this case, it snaps and it breaks off. But I just want to show you this part as practice, just in case it didn't break. So let's say the max tension was instead 100 newtons, then this would be the tension on the string. Right. Next one, there's a brick on a concrete floor. Mu s is equal to 0.82. Mu k is equal to 0.41. And the brick has a mass of 4 kilograms. And we're pushing it with 3 different forces, or 3 different amounts. 28, 31, 33. Okay, so first thing you want to ask is, will it move? So to do that, you need to find force of static friction, which is mu s Fn. Here Fg is 4 times 10, negative 40. So that means force normal will be positive 40. So 0.82 times positive 40. And looking at my cheat sheet, I get 32.8 newtons, which is force of static friction. All right, then you go, okay, my applied force has to be bigger than this in order to move. 28 is less than 32, so will not move. A equals 0. This one is also less than, so again, will not move. A is equal to 0. This one is bigger than, so once it's bigger, we don't care for this. We just need kinetic. So force of kinetic friction is equal to mu k Fn. Plug in that value, which happens to be half. Doesn't always have to be, but in this case it is. So I could do that math in my head, but I didn't mean, or sorry, this is newtons. 16.4 newtons. So then you do a summation. Sum of all forces is equal to, so you have force applied, force of friction. So you have force applied plus force of friction, and you plug everything in. M is 4, A equals force applied, in this case is 33, minus kinetic friction, which is 16.4. And then you get, see, whatever this is divided by 4, because I don't have my calculator with me, 4.15 meters per second squared. Okay, so that is that one. All right, on to our last problem, which is a classic Atwood. You have mass 1 here. Oops, I put I. Mass 1, a pulley, mass 2, and then it's on a table, and it is at rest. Okay, and it has a mu s of 0.6, a mu k of 0.4, and then what do we know? And this is 10 kilograms. I think that's it. All right, here we go. So the question is, what force will it, or what's the minimum mass here that will cause it to move? So it's just a pure like friction problem. So you have this mass that's pointing down, force of gravity 2, which then will cause a tension. So this tension right here is pretty much going to be Fg2. Remember, tension just transfers force from one object to another. So here we have force of gravity of the 10, so 10 times 10 will give me 100. So that means this is positive 100. And then we want to know how much static force is. So let's calculate it. Force of static friction, I said force, but I meant friction, is equal to mu s Fn. Mu is 0.6 times 100, which give us 60 newtons. So that means it needs at least 60.000001 in order to get this thing moving. Now, just to make life easier, let's just say it's 60. So 60 tension here, which means we'll equal 60 tension here, which means this force of gravity needs to be 60 newtons. So if this mass provided a gravity of 60 newtons, then this thing is on the verge of moving if it was just that tiny bit more. All right, so I didn't have the mass, but I gave you this, or you're able to determine this, but you can figure it out. This is equal to mg. G in this case is 10, so 60 divided by 10 gives me 6 kilograms. So just remember, equals m times 10, 60, so m is equal to 6 kilograms. All right, so that's the first one, was what is the minimum mass that could barely set in motion. Technically it's 6.00001, but 6 is fine. Then the next one is, once it's moving, what's its acceleration? So once it's moving, we don't care about static friction anymore. What we care about is kinetic. So kinetic is 0.4 times Fn. So that will be 40 newtons. Then you do a summation. Sum of all forces is equal to, and then you want to do a direction of motion. It should go to the right and then back down. So this now is kinetic friction is opposite direction. So it's negative force of kinetic friction. This is same direction plus tension. This is opposite direction minus tension. And then this one is width, so plus force of gravity 2. Plug in everything you know. Ma is equal to negative 40 plus t, negative t cancels out, plus Fg2, which is 60. The mass is of the whole system, so be careful here. 10 plus 6, A equals 20. So A in this case is 20 divided by 16, or 1.25. Okay, so hopefully that makes sense. And then if I ask for tension, then you just isolate one of these and solve for it. So let's say I didn't, but let's say I did. So if I ask for tension, then you just isolate one. It could even be the top one. It's whatever one you choose. Let's do the bottom one because there's less forces. Force of gravity is equal to 60. Acceleration is down, and that's equal to 1.25. And then you have force of tension, which is unknown. And the only thing you have to be careful is this is down and this is down, so these two have to have the same sign. So you can make them both negative, but they both need to be the same. So the mass of this one was 6 times 1.25 equals t minus 60. I have no idea what that is. So 6 times 1.25 is negative 7.5 plus 60 will give me a tension of 52.5. So if I ask for tension, that's how you would find it. And I always like to do a test. 60 is bigger than 52, so it should accelerate down, and my calculations did give me a positive in this case, which is down 1.25. Email me if you have any questions. Other than that, good luck tomorrow.